Very good morning, my dear students. Welcome to the another session of Numerical Academy digital classes. Today, we are not going to start a new topic. I'm just going to revise the Newton's three laws of motion along with the numericals, especially based on Newton's second law of motion. Let's start the quick recap about Newton's three laws of motion. What we are going to do today is a quick recap on what? On three Newton's laws of motion. Clear? Number one, what was the first Newton's laws of motion and its statement? It was what we had discussed. Every body wants to be in the state of rest or in the state of uniform motion unless it is acted upon by an external force, right? So we know about the statement, we had discussed in detail, right? Of course, we have spent almost 1.5 class on Newton's first law of motion itself. Again, I'm not going to do that, right? Number two, what was the second statement of Newton's laws of motion? A second law of Newton's laws of motion. The statement tells that the rate of change of linear momentum, is directly proportional to the net external unbalanced force. And it is directed always along the net force, right? So about this also, maximum 2.5 classes we had spent in discussing Newton's second law of motion completely. Now, number three, what was the third law of motion? So I know this is the favorite law for most of the students, right? What was your favorite statement? Newton's third law states that every action has an equal and opposite reaction, right? So about this also we had discussed almost a full class, right, to understand Newton's third law of motion. And listen to me once again about all the three laws of motion. The number one, everybody wants to be in the state of rest or in the state of uniform motion unless it is acted upon by an external force. In a short way, how to remember all the three Newton's laws of motion easily, I just wanted to tell you in this class. How to remember all three Newton's laws of motion forever, lifetime, easily. There are some easy method to understand the three laws of motion, right? So number one, and look at the first law here, what it tells. It tells about the requirement of the force. What is that? A requirement of the force. Yes or no? The force is required to start a body and to stop a body. Look at here. So every body wants to be in the state of rest or in the state of uniform motion unless it is acted upon by an external force. So requirement of the force it tells about. So to start a body, you need a force. To stop a body, you need a force. Anything, right? Imagine there is a football which is at rest. To start it, you must apply a force on it. That's what, to start a body or to stop a body, there is a force required. Okay. So football is moving towards you. To stop it, you need to apply a force. Yes or no? So that is what? The first thing. And the second thing. The rate of change of linear momentum is directly proportional to the net external unbalanced force, and it is directed always along the net force. And the second law, simply I can write F is equal to ma. If somebody asks you what is Newton's second law of motion, you should not tell that F is equal to ma. F is equal to ma is the final expression what we derived based on the statement given by Newton. Understand? So just for our recollection or for our quick recap, and let's assume that your second law of motion is F is equal to ma. Clear? And number 3, every action has an equal and opposite reaction. So from this third statement, what you should understand, so far there is an action, definitely there will be a reaction. And let's see the first law, what I wrote, requirement of a force. To start a body or to stop a body, force is required. And what is that force? F is equal to ma. One force if you apply, there will be a reaction force, and it's the flow, right? But the method I have not yet disclosed. Okay, this is not the shortcut. Just I have written short form of each and every Newton's laws of motion. Now it's time for you to learn the short story which will help you to remember all the 3 Newton's laws of motion forever, right? I hope you all are ready and listen to the story. One day there was a shepherd who takes care his sheep and goats. He has taken all his sheep and goats to the forest, and they are on the way to search for their food. After some time in the forest, all the sheep and goats have suddenly stopped moving forward. Just stopped. The shepherd got surprised and he could not understand what to do that. How to move them. He shouted a lot on them. At one point of time, he has taken a big solid stick and started beating them, and they started moving forward. What is the conclusion here? What you should understand from this part of the story? To start a body, to stop a body, we need to apply a force. They all have stopped. Once the shepherd had applied a force on them and they started moving, right? First law is justified or not? Tell me, everyone. First law of motion justified or not? 100% it is justified. A force is required to start a body or stop a body. It's fine. As soon as he has beaten them, the all sheep and goats have screaming like anything, and they are screaming as meh. What is that? Meh. So that's the language of the sheep and goat. Understand? If you have observed at any point of time, so meh is the language of the sheep and goat, right? So that's what this M-A. What is M-A? It's not ma. It's meh. So F is equal to M-A. As soon as he applied a force, and you can see here, all goats and sheep have screamed like this. Your second law of motion is also justified, yes or no? 100% it's yes. Now the interesting part. As soon as he applied the force on the goat, if you assume that that force is action force, the goats have also given him back. He applied a force on them, goats also kicked him back. If he applied a force, that is called action, goats also applied a force on him, they also kicked him back, so that force is the reaction force. For every action, there is an equal and opposite reaction. Do you think the third statement is also justified? Yes or no? 100% it is yes. So look at here. So this is also justified. I hope you could recollect, remember forever the Newton's 3 laws of motion by using the simple and small story. But I'm requesting you not to write this story in your board exams or in your college exams, right? Because those are not the Newton's 3 laws of motion. These are not the Newton's 3 laws of motion. These are the Newton's 3 laws of motion, right? Understand? So this is about the quick recap and how to recollect Newton's 3 laws of motion forever. Now let's solve a few numericals based on the same Newton's laws of motion. Then we will be moving into the next concepts. See, my dear students, here. Now the numericals what we are going to discuss are NEET, JEE, CET, previous year questions from our discussions so far. So far we have discussed only Newton's first law of motion, second law of motion, third law of motion. Of course, in the second law of motion, there are the topics called linear momentum and impulse and similar to them. Some concepts we have discussed, including them. What are the discussions so far we have made through these online classes? The questions they have asked in the NEET, JEE and CET in previous years, and those questions we will see, right? Number 1. A car is moving with a speed of 50 kilometers per hour. Can be stopped by brakes over a distance of 6 meters, sorry. This is the car is moving. It can be stopped by applying the brakes. What does it mean? Look at here, carefully. So imagine this is the ground. There is a car. I'm not going to draw my own design here. That will be discussed later. That will be drawn later. A car is moving with a constant speed. Suddenly it has seen a vehicle here. Definitely the person in the car will apply the brake. Okay. Imagine he is moving with some initial velocity u. At the time of he has seen another vehicle which is coming other side in opposite direction, he applied the brakes. Then what happens? So the car will move to some distance, right? And comes to rest. Clear? The car will move to the some distance before it comes to the rest position. And that distance is called stopping distance. And what is this distance called? Tell me, what is this distance is called? A stopping distance, okay? Because we applied brakes at this point and car is stopped at this point. That is called the stopping distance, right? So it depends on the ability of the driver and depends on the efficiency of that particular vehicle and the condition of that particular vehicle. The stopping distance may varies. Okay, now let's come back to the question. A car is moving with a speed of 50 kilometers per second per hour can be stopped by brakes over a distance of 6 meters. Here stopping distance is how much? 6 meters. Okay, now if the same car is moving at a speed of 100 kilometers per hour, then the stopping distance will be, right? There are two conditions. What are the two conditions here? First case, number 1. First case, what happened? Initial velocity of the car is how much? 50 kilometers per hour. So that I can write into the meters per second. 50 into 5 by 18 meter per second. And stopping distance in this case, imagine the first case and this is U1. First case. Stopping distance in the first case is how much? 6 meters. Now the second case. What is the second case here? If the same car is moving at a speed of 100 kilometers per hour, so initial velocity in the second case is 100 into 5 by 18 meters per second, and stopping distance in this case we need to find out. Okay. Here, a car is moving with speed of 50 kilometers per hour here. If the brakes are applied here, the car will come to rest with uniform retardation. With what? Uniform retardation. So that's a A, for example. Uniform retardation is A. So equations of motion can be applied when a body is moving with uniform acceleration or uniform retardation. Clear? So from the equations of motion, so what I can write, which equation of motion I can use here? In any case, either you take this case or this case, whatever may be the case, what is happening? Final velocity is 0 and displacement is S. Uniform retardation A and initial velocity U. Is there any time is mentioned here? No. So as there is no time is mentioned in these given cases, we can use the third equation of motion, which is V square minus U square is equal to 2AS. V square minus U square is equal to what? 2AS. Is it clear? Clear. Now, in any case you take, as V is equal to 0, what I can write? Minus U square is equal to 2AS. Okay, clear? Now, minus indicates only the uniform retardation it is, you know, right? When A value is negative, when acceleration value is negative, so that's called uniform retardation. Okay, so in both the cases, braking force what we applied is same. Yes or no? Only the car is moving with some particular velocity. That velocity will be different. Braking force we are applying is same. When F is same, acceleration also will be the same. Okay, because F is equal to ma. M is constant. When F is constant, acceleration also will be constant. So now, one acceleration is constant. This 2, it is anyhow, it's a constant. So what I can write from here? U square is directly proportional to stopping distance. Yes or no? Will you agree this or not? According to the constant of proportionality, this U square value will be directly proportional to this S you can see here, right? So this I can write in terms of ratios also. How I can write in terms of ratios? U1 by U2 whole square is equal to S1 by S2. Okay, you know U1, U2 values and you know S1 value, S2 it is easy to find out. Okay, so let's find S2. U1 by U2, what is U1? Yours 50 into 5 by 18 divided by U2. U2 is 100 into 5 by 18 whole square, which is equal to S1. What is S1? 6 by S2. Okay. Clear? So this 5 by 18 cancel here. 0, 0, 5 ones, 5 twos. So 1 by 2 whole square is 1 by 4, which is equal to 6 by S2. So cross multiply, it is S2 is equal to 6 into 4. How much? 24 meter. Whether your answer is correct or not, how do you check? That's an important point, right? In most of the questions it is possible. This condition is possible. You can check whether your answer is correct or not. Definitely this relation is correct. U square is directly proportional to S. When at the time of applying brake, initial velocity square is directly proportional to the stopping distance, right? More is the velocity the body is moving with at this point, at this moment, more will be the stopping distance. That's it, right? If the car is moving very fast, we apply the brakes, definitely stopping distance will be more. If the car is moving slowly, you apply the brakes, immediately the car gets stopped, where the stopping distance is very, very less. The same concept applicable here. Initially, when speed of the car is 50 km per hour, the stopping distance is only 6 meters. When the speed of the car is 100 km per hour, definitely stopping distance will be more than 6, right? So that is 24 meter. Understand? So this is how numericals will be asked. See, this is one of the previous year NEET exam question, right? Not only the NEET exam, commonly asked question in the NEET, JEE and the CET questions, right? We'll see one more question now. My dear students, let's see one more question here. A ball of mass 0.5 kg is moving with a velocity of 2 meters per second. It is subjected to a force of x Newton in 2 seconds. Because of this force, the ball moves with a velocity of 3 meters per second. The value of x is. So many numericals we have solved so far in Newton's third 3 laws of motion. If you feel that you could solve this question, just pause the video and try yourself. Anyhow, you can recheck the answer by revising or playing the video. Okay. So, but it's not compulsory for everybody. Listen. If you feel that you could solve this numerical without my support, and you can definitely do that by pausing the video, the rest of the students concentrate here. A ball of mass m. What is the mass is given? 0.5 kilogram. It is moving with a velocity. Already it is moving with a velocity 2 meters per second. I can see that is the initial velocity 2 meters per second. It is subjected to a force of x Newton. So force value is x Newton and the time is given as 2 seconds. Listen. A force of x Newton acting on a body for 2 seconds. So what is the concept you must recollect now? A force acting on a body for 2 seconds. That's a concept called impulse. I hope you could recollect it. Impulse. What is that impulse? Impulse is equal to change of linear momentum. Change in linear momentum. And what I can write here, impulse concept, F into T is equal to change in linear momentum, M into V minus U. That's a formula behind this question, right? 90% of the physics questions in CET exam, I'm talking about CET exam, yesterday or day before yesterday only, the CET exam is finished. 90% of the questions you can solve in CET just by recollecting the proper formula. 90%, whether you believe it or not, 90%. Whereas in NEET and JEE questions also, minimum 60% questions will be asked just based on the formula. If you could recollect the formula, then you could answer that. Rest 40% questions only application based questions will be there, right? So based on the application based questions only, the ranks will decide. Okay, now let's use this formula. What is the F value here? X into, what is the time? Time is given as 2 seconds, which is equal to M. Mass is given 0.5 into V minus U. What is V here? After applying this force in 2 seconds, because of this force, the ball moves with a velocity of how much? 3 meters per second. So final velocity they have given as 3 meters per second. And let me write that final velocity is 3 minus initial velocity is 2. Okay. So what is this? 2x is equal to 0.5 is 1 by 2 into 3 minus 2 is 1. Your x value is 1 by 4 and your x value is 0.25. What is the unit? Is it the meter? Tell me. Is it the meters? No. So the x value is just 0.25 here. So the force of x Newton. So that means x is 0.25. You get here? Force of x Newton. Your x is 0.25. The question is just find the value of x. That's it. There is no unit for this x. Okay. So for this force there is a unit. For this force there is a unit. X is just a magnitude they are asking. So indirectly they are asking the question, what is the magnitude of that force? What is that? 0.25. That's all. One more question. So my dear students, look at this question. A machine gun is mounted on a 200 kg vehicle. This is the vehicle on a horizontal smooth road it is placed. The gun fires 10 bullets per second with a velocity of 500 meters per second. If the mass of each bullet is 10 grams, what is the acceleration produced in the vehicle? That's a question. Acceleration produced in the vehicle. Okay. So the acceleration produced in the vehicle we need to find out. Right? Let's begin this. And this was the question asked in previous JEE exam. Right? Not even in the NEET exam. It's a little higher level question. Right? Now let's start. So simple. There is ground. A car is placed here, and you know my own design of the car. Okay. Now, a machine gun is placed on it. Like this. A machine gun is mounted on a 200 kg vehicle. I am writing about a car and the bullets. This is the car. What is the mass of the car? 200 kg. On a horizontal smooth road, the gun fires 10 bullets. So how many number of bullets? 10 bullets in 1 second. With a velocity of 500 meters per second. Initial velocity of the bullet is 0. Final velocity, that means before firing there is no velocity for the bullet. It will just sit inside the gun. Once the force is applied, then the bullet will move with a velocity given 500 meters per second. Mass of the each bullet is equal to, what is that? 10 grams. That 10 into 10 raised to minus 3 kilogram, because everything is given in SI units and I need to convert this mass of each bullet also in the kilogram. Now, what is the acceleration produced in the vehicle, right? So much data is given about the bullets, but the question is asking about acceleration produced in the vehicle. Look at here. First, what happens? The gun will apply a force on the bullets. That is what I am writing here. Force on the bullets by the gun. What is that? F suffix BG is force on bullets by the gun. Here, which body will accelerate? Gun or bullet? Force is acting on bullets, so these bullets will accelerate. Clear? These bullets will accelerate. Same thing. If it is an action force and there will be reaction force. What's a reaction force? Force on the gun by the bullets. Understand? Force on the gun by the bullets. Here, as the gun is in contact with this car, if you say that it is action force, definitely the reaction force will be acting on the gun. So gun is contacted with the car, and on this car the reaction force acts. I hope you got the point. Action force is on the bullet. Reaction force is on the gun. As the gun is in contact with the car will move backwards, little backwards due to reaction force, right? Now, here I am writing here. Force on the gun by the bullets is exactly equal to force on the car by the bullets. Yes or no? Because this gun and car are in contact. Clear? Now, as this is action and reaction force, what I can write? F suffix BG is equal to F suffix G B, right? Now, what is F suffix BG? This is about bullets. This is about gun. So that means this is also about this one. I am talking about this. This is also about a car, right? Now, this one, let me write. Force on the bullets, mass into, there are n number of bullets, n number of bullets into acceleration, v minus u by t, which is equal to, this is about bullets. And the other one is about car, a mass into acceleration. This is about car. Car, because only acceleration you need to find out. Now, this is m. What is m? This is mass of the bullet. What is the mass of the bullet? 10 into 10 raised to minus 3. So, can I say that it is 10 raised to minus 2? Definitely 10 raised to minus 2 into how many number of bullets? It's 10 into v minus u. What is final velocity of the bullet? 500. Okay. Minus initial velocity 0 by time is 1 second, which is equal to, this is about car, I said. Mass of the car is how much? 200 kg. So it is 200 into acceleration of the car you need to find out. Now let's start. 10 raised to minus 2 into 10. Right? So what I can write here? It is 10 raised to minus 1 into 500, which is equal to 200 into A. Right? So this is 2 zeros and 2 zeros cancel here. So what I can write, 2.5. So it is 2.5 by 10. 2.5 by 10. 2.5 by 10, I can write it is a 0.25 meter per second square. What is that? 0.25 meter per second square. That's what? Acceleration of the car. That is what? Acceleration of the car. I hope this is the problem, is an easy problem what we have discussed now. There's no difficulty in it. Two things. One is about unit conversion and second one is about there is a reaction force on this gun. As the gun is in contact with the car will be moving backwards with a small reaction force which will accelerate the car just a 0.25 meter per second square. Okay, and let's see one more problem. Okay, students, see the last numerical of this session. A stone is dropped from a height of h. If it hits the ground with a certain momentum p, we discussed already. Imagine this is the ground. So there is a stone which is dropped from a height what? From a height h. It is reached the ground or hits the ground with a momentum p is equal to mv, where that v is root 2gh. I hope you could recollect this one, right? From how? P is equal to mv. So this v I can write from here, v square minus u square is equal to 2gh. Anyhow u is 0 here. So what I can write, v is equal to root 2gh. No confusions at all. For the new joining students, I am just writing like this. I am just explaining here. Now, this is the P. That's P here. If the same stone is dropped from another height of 100% more than the previous height, initial height is h. 100% more means it is double. Yes or no? Tell me. 100% more means it is double. Okay. So now there is a same stone which is dropped from a height of 2h, 100% more. The momentum when it hits the ground changes by, right? Imagine at this point, so the momentum, it's P is equal to m into root 2g into 2h. If you consider this is P1 and this is P2, what is the question? The momentum when it hits the ground changes by. Percentage changes they are asking, you can see here. 68%, 41%, 200%, 100%. Whenever there is a question based on the percentage change, right? How to find the percentage change? I'm just writing here carefully. See, percentage change in any physical quantity they are asking, right? So the formula is final value minus initial value divided by initial value into 100. Any physical quantity percentage change if they are asking. Final quantity, for example, percentage change in the velocity. Final velocity minus initial velocity by initial velocity into 100. Percentage change in the mass. Final mass minus initial mass by initial mass into 100. Here, final linear momentum percentage change they are asking. Percentage change in the final linear momentum. Final linear momentum minus initial linear momentum by initial linear momentum into 100. That's it. You get the answer. Okay. And let's start. So the question, percentage change is equal to, what's the final linear momentum? It's P2, right? So let me write P2 minus P1 divided by P1 into 100, right? So what is P2? P2, let me write here, M into root 4GH. Yes or no? 2 into 2, 4GH. Minus M into root 2GH. Divided by P1. What is P1? M into square root 2GH into 100. Okay. So in the numerator, what I can take common? M into root 2GH I can take common. So what is here? It will be root 2 minus, and the complete value is taken common, 1 divided by, what is remaining? Denominator M into root 2GH. So numerator and denominator cancels like this. So it is into 100 is also left. So what is that? Root 2 minus 1. Root 2 value is 1.414 minus 1 into 100, right? So the answer is percentage change, which is equal to, what is that? 0.414. 1.414 minus 1 is 0.414 into 100. 1 0, point will come here. Another 0, point will come here. So 41.4 is the linear momentum will be changes by 41.4, right? So option B is correct. So concept here. Two things. Simple. When the height is increased, definitely linear momentum will increase. At the point of hitting the ground, the linear momentum transferred by the ball to the ground will also increase. How? Linear momentum is increasing. So M into root 2GH, M into root 2GH. Right? Clear? Here, linear momentum is increased. How much it is increased? How to find that percentage change in the increased value, percentage change in the increased value, final value minus initial value by initial value into 100. So these are the percentage changes in the mathematics you might have discussed in the lower classes itself, maybe 7th or 8th standard itself, right? But still, I had discussed the introduction, then numerical. Okay, clear? So just practice all these questions and you will be getting your assignment today soon.